Okay, welcome to Nested Loops. We're actually doing what, chapter 21 and 22? Is that correct?
21.
I thought we were supposed to do 20, little logistical mistakes, so we'll come back and do 20 after the fact, and hopefully it's not ineffective. So I'll turn it over to Brett, who's got 21 and 22.
Oh, sorry, I only did 21.
Oh, you only did 20? Okay, well, we only did 21.
It's very short.
Perhaps if we have enough time, we'll go back and do 20 in real time.
All right. The singleton pattern and the double-checked locking pattern. So yeah, pretty simple chapter. This chapter continues the e-commerce case study introduced in chapter 9, the strategy pattern. It's pretty short though. So it illustrates how a factory can control the number of instances of an object that can ever exist using the singleton pattern, and some other things. I actually had trouble entirely putting together how the factory was connected to the singleton. I guess I maybe glossed over the factory section. So the singleton pattern and the double-checked locking pattern are very simple and very common. Both are used to ensure that only one object of a particular class can be instantiated. The singleton pattern is used in single-threaded applications, and the double-checked locking pattern is used for multi-threaded applications. To tell you the truth, until I read this, I never heard of the double-checked locking pattern. But I also have never programmed a production application that required multi-threaded or threading. The gang of four basically says to ensure a class only has one instance and to provide a global point of access to it. Does anyone have any questions yet or any comments? I think we probably most of us have seen the singleton pattern. Okay. The singleton pattern works by having a special method that is used to instantiate the desired object. When this method is called, it checks to see whether the object has already been instantiated, and if it has, the method just returns the reference to the object, and if it hasn't, it creates it, instantiates it, and returns the reference of the new instance. The way that this is done typically, I guess, is to define the constructor of this class to be protected or private. So you're not really calling new on the object, you're calling some other method, which will in turn call new, depending on what language, I guess. So one of the important aspects of, let me see where this is. One of the most important aspects of this singleton is basically when a change is made to the instance by one collaborating object, the other one needs to be able to see the change. And I figured to myself, there's probably a lot of times where I don't use the singleton and I do it some other way. I guess with web development, it might be different than other types of applications. But I mean, I even see me putting information in databases and just instantiating over and over. So yeah, that goes into, for performance reasons, you may not want to keep instantiating the same object over and over and throwing them away. And there's this note about, although you could instantiate all the possible strategies at the start, this could become inefficient if the number of strategies grew large. Does anyone have any comments or questions about any of this or thoughts?
Straightforward to me.
Yeah, it's pretty straightforward. I guess the about this, in a Ruby or I guess a Rails web application, what would be an example of this particular thing? Are we talking about like in an initializer or something? Or Forrest, if you could That was one thing that I had trouble seeing is like,
So
what is the
yeah,
method
so
between?
a lot of these patterns make sense in like long-lived applications versus the problem with web apps and
Right,
states. To the browser, you don't know anything. The other side, I have to act as if I have no state. So everything is stored in the request to get the information. So if you have a long-standing, I'm going to make up a scenario based on this tax thing. Let's say I'm starting up TurboTax, right? And this is going to be an uprunning. And let's say in TurboTax, there's like 50 kinds of tax profiles. And we'll say
right,
every profile takes 5 seconds. So I don't want to do 50 times 5 to start up.
right,
Right. What'll happen is realistically, I'll have like maybe 2 profiles. Maybe I'll do the married and filed jointly or married single, and maybe I want to figure out which one is cheaper. So at most I want 2.
right,
So it makes sense when I click the married filed jointly, I get that one. Then I decide, oh, let me run this again with another one. I click the other one instead of waiting for all 55 types to do it. So that's an example of let's not instantiate all up front. And again, because basically I start up TurboTax until I shut it off versus, I hit the web server one request at a time, storing, all persistent stuff often in a database or, everything for parameters. So that's more of that kind of thing. But the same thing would happen
yeah,
if I hit a controller, if I had the TurboTax website, when you hit the controller, start tax profile, I don't want to install all 50 then either. But the difference is once that request is done, the controller, might even go away. That's kind of what I believe Rails does. That object. Every time you get a request in Rails, what it possibly does is Rails makes it, controller.new and handles that thing and then gets rid of the object. That gives you a clean state. That's, arguably, it doesn't have to do it the way. It might pool.
it doesn't have to be a singleton, but
Right.
it could be.
But it would make, the simplest programming model is instantiate a new one and then handle the thing and then get rid of it. Right. And so you can see that has a short life where, I might have TurboTax open all weekend. So there's a little difference, and again, we don't know how Rails does it. Rails could do it. Rails might pool them. Rails might recycle them after 10 uses. Rails might never recycle them, for a 7-millisecond startup time savings. I don't know. But I think the easiest way to do that is very typically OO is, controller.new, controller handle action, done. So.
Yeah. So yeah, I guess that just trying to compare it to like instance variable. I guess if you wanted a singleton of some object, maybe you could pass it across the views of the controller. Yeah. Okay. So instead, it would be best to instantiate them as needed, but only do the instantiation once. One problem, or the problem, is that you don't want to create a separate object sometimes so that you can keep track of what you've already instantiated. So let me see where I had this note. Basically, what this section is getting at is you would like to have the objects themselves, that is the strategies, be responsible for handling their own instantiation versus you don't want to have to create a separate object to keep track of what you've already instantiated. And basically at the end, he just says, this is the purpose of the singleton pattern. Enables me to instantiate any object only once without requiring the client objects to be concerned with whether it already exists. He goes into some implementations about this. Basically, this US tax that extends tax, blah, blah, blah. You have an instance, in get instance. This is private. This is also private. All Java, so it's a little different to me. And basically, if it exists, return the one that's there. If it doesn't exist, create a new one and return that. He talks about that whole concept of he wants the client objects to be concerned about whether it exists already, and he has this example. Again, it's Java, so it's just some of it's stuff that either I wouldn't work with on a daily basis or just implementations of it. But basically, from what I see is there's this tax object and there's a US tax object, and they both have the same get instance method. I really didn't fully understand this. So if anyone
Well,
has any comments about it.
because we skipped the factory.
Right, right.
So the first one is the factory. Your app doesn't care about what tax type you get as long as it's a type of tax. Right. And then the second one is, well, in the US do US tax, but in Canada do Canada tax.
Got it.
Right. So the first one just does the other,
So you might, but I guess in this situation, are they saying you would never use this, or you could?
The program that used US tax is bound to US tax. If you had a general tax program that, could handle multiple countries, right? For you to call US tax somewhere sort of binds the knowledge of US tax there. So you're using one level in direction to put it off. So the code that uses tax can handle any tax in theory.
Yep. Yeah.
I think one of the considerations here too is that when you are extending a class that's already singleton, you want to make sure that the instance that you're storing, since it's a static attribute, that you have a separate one for each type, at least in some cases. So that extends tax.
Got it.
Makes this more complicated.
All right. So let's overview. This is just a picture of how there's get instance and how these are private. And I love how this chapter says, if you're not involved with multi-threading applications, you might want to skip this section. We'll go over it, but yeah, never heard of it. Never had to use it. Has anyone here had to use the double check locking pattern?
I don't know if we called it there, but you hit that issue with multi-threading, yes.
Yeah.
Well, I was going to put it to the end, but singleton, well, there are certain concerns that change it, but for the most part, singleton becomes global data. It's the, if global data is considered harmful, then this is the less harmful version of global data. And so since we're already in a double checking locking pattern, the place that you would use global data if you weren't good at OO, that's roughly where you might use singleton.
Right. The one place I've used singleton many times is JavaScript. JavaScript, yeah.
Right, and so you have, and that's a good example. JavaScript, where again, because we're not talking like Rails controller, which doesn't make as much sense because again, if the controller goes away after every instance, not so important. But like if you're running JavaScript in the browser and it's up, as long as the page is up, you have various objects talking to each other, and you kind of want this global, and a lot of times people just use the global, where you have multiple people talking. In some cases, singleton can store global data, which is one use, but it's also, in the case of the tax thing, it's data and knowledge. And the reason you would make it global instead of reinstantiating every time is usually performance related. If it's cheap, just make a new object. It makes for the cleanest code, but if it stores state, then you can't instantiate every time. So if you're storing, that goes back to the global data again. If it stores state, you don't want to reinstantiate every time. And so if I have a bunch of objects hitting this global state, then that becomes an issue when you're threaded, because of, that's why you have locking and all the stuff that when you read about threads and data that start to freak you out because you're afraid of getting, locked out of your data or getting inaccurate versions of data, or who has access, who has read accesses versus write access, all that stuff. All those complexities change with multi-threading stuff versus a single-threaded app where, you know, one thing is hitting that global data at a time.
So probably going about 10 years back, and I was probably behind, but I remember I was using global left and right with JavaScript. Probably just a poor understanding of JavaScript, because I'm sure that the creators or people that knew more weren't doing that. But it seems like that was just like a bad habit, not just from me, but the whole a lot of JavaScript
I think
developers.
the amount of time you see a window dot blah blah
It's
is
crazy.
like, I think it's still in widespread use. Like
Right.
if you look at React, React tries to do away with that with stores. Stores are basically a singleton,
Right.
which, you know, your various components will go and talk to you. It's global data with the name that doesn't sound as bad as global data.
Right. So when I realized how bad it was, quote unquote, I started to try to use singletons when I could, when it made sense to me.
But the value of singleton in part is, like, if you see the technique that you do here, is all the Java goes and makes the constructor private. So the key is control of who gets to create this. So in some ways, and Ruby code tends not to be as protective like this. Making the constructor private means there's only, like, you limit the way you can create it, which also is a useful technique otherwise. That's why you use factories in general. If you want to control, if you just allow anyone to do object.new, then they could do it wrong. And so, you know, code that uses like maybe 3 factory methods, these are the 3 allowable ways to make objects, and then makes, you know, the constructor private, forces the users to use the three allowable ones and not come up with a 4th unallowable one. Right. So one thing, and I think they must mention this in the factory thing, is this controls your rules of not of how you create the singleton data, right? The singleton is just a class, but you could possibly create the class wrong.
Yeah. So
the singleton does both. He talks about being responsible yourself. It creates the class in the only right way. And there's only one way for you to call it, the get instance, which, you know, in this case, in the example case, just did a new, but it could be a new with 11 parameters that are the right answer. And the other thing that this method, oh, sorry, someone's at the door. This is probably my computer or something.
So yeah, I guess what I was gonna say is having only really used singletons in JavaScript myself, never had to even think about multi-threaded. I don't know if that's because JavaScript isn't multi-threaded support, or the browser doesn't allow it, or if it's just natural that it locks it all. Anyone have any idea?
I was actually just looking it up to see, because you know, obviously there's like a lot of callbacks used in JavaScript, and you would think that with these independent events going on, that you would actually have some sort of problem with you know, needing to lock or having multiple threads running at once. But apparently, the JavaScript engine is written to only do one thing at a time.
That's what.
So
Yeah.
it's like a single thread of execution, and it might bounce between.
Processes.
I don't know if this is actually like valid, because to me, it seems like they're kind of dismissing that there might be locking problems in a JavaScript program, because you can still have something that has read a value that's global and then like waits for IO, like for an async request to come back, right? And then while it's waiting, something else could be happening and modify that value. And then later that event resumes. So I still feel like there should be more discussion of this, like locking in JavaScript. But apparently people just kind of dismiss it as not being a problem, since there's only a single thread of execution.
Do you have any knowledge on that for us? I was asking, like, yeah, I've never had to worry about or even think about multi-threaded even though in JavaScript is one of the few places I've used.
Yeah, I mean, the example that Don says is true. That you can hit the same. You can hit similar issues for multi-threading Whereas if you don't time, if you grab a value and then you're waiting for an IO thing, someone might change what that value is underneath you while you're waiting. The difference with multi-threading is that it's more concurrent, which exacerbates. It's worse under multi-threading because things are concurrent. In JavaScript, it's asynchronous, but depending on how long that IO thing comes, you could get out of sync. It probably, with short calls, it doesn't happen that often.
And I think maybe either the frameworks or something, or just the way that we develop in JavaScript kind of helps us protect against that. Because maybe not. That's just what I'm thinking.
It's also the measure of the kind of programs you write.
Right.
I think your atypical GWiz Ajaxy UI probably doesn't have that issue.
Yeah. And I think like for us with Ruby and to some extent, of course, JavaScript is web-based. Although we've talked about these examples where it's very clear that there are multiple execution paths that simultaneously exist in JavaScript. In Ruby, that's almost never the case, except for the things like database connection, which Rails handles with a singleton and a connection pool, like we talked about. So it's kind of handled for us, and we don't have to worry about it. But in things like Python, when you're doing like scientific applications and you have multiple concurrent things running, this is a huge topic of discussion. And it's actually very similar to JavaScript. If you use the native threads in Python, there can actually only be one running at a time. So the Python interpreter is just switching between the threads. There's other things you can do at like the C level to run multiple threads simultaneously, and there's like a lot of libraries and discussion about this. But even though it's still the same thing as JavaScript, where there's only one thread executing at a time, there's still a huge discussion about locking, whereas JavaScript seems to dismiss it. I don't know if they're doing something special that we don't know about. To like, for example, maybe they're doing some sort of locking in the DOM, because that's the thing. Even if you're not using global variables in JavaScript, the one global thing that you're modifying all the time is the DOM, right?
Yeah.
So yeah, I don't know how they handle that.
That might be exacerbated by using web workers. So I've actually not done much reading on that one, but I think that opens up a can of worms.
And I could also I could see how the Python community, because they're doing so much data science with churning of data, they really do need to leverage multi like that type of concurrent processing a lot more than we would, or you would in the browser.
Yeah, exactly. But there's still like the mechanism is very similar to JavaScript, from what I just read at least, that even though you're only executing one thread at a time, you still have to worry about blocking.
Interesting.
Yeah, because of like what Forrest said, is like, yeah, you might read in a value or modify a value and then block to do something with IO, like to wait on a web request to come back. And then some other thread would take over and start working on that value. So you can very easily get out of sync. I don't know why we didn't encounter that very much in JavaScript. Maybe because it's just so fast that when you click something, typically you can only do one human action at a time, right?
Sorry. In JavaScript, every tab has a single process dedicated for the JavaScript, right? It used to be like on one browser will share all, like one process for all the tabs. Now it's like each tab gets its own JavaScript process.
Yeah, that's different than what I think we're talking about.
And I think like when we talk about asynchronous requests, that I don't think that's a valid idea of multi.
Right. Yeah.
It is though, because that's the same thing that people are talking about in other languages as well. Is like when you're doing an asynchronous request, you actually do have like a separate thread of execution, and even if it can't run at the same time, you could be switching between threads constantly. So you have to keep in mind.
It's still a single threaded, right? So like you don't have real multi-threading. So like real multi-threading, I guess, is similar to web workers, which is when you do a web worker, you're instantiating almost a new page, right? So you actually, within the same, with this, I guess, the same process, you have multiple scripts running at the same time concurrently. While you do asynchronous stuff, you're not actually running anything concurrently. You're just waiting for a response.
That's, yeah, you're
From
not running.
someplace else. So you're not really running anything concurrent. Okay, and the thing like swapping underneath, something else can swap or change in the state internally. That is true, but that can happen even without multi-threading.
Yeah, I think that's what we're all saying here is that, like, if you have multiple like paths of execution that exist simultaneously, even if they're not running concurrently, it's still very trivial to create an example where you like read in global variable A, and the value of it may change the next time that your thread gets to execute, whether we call it like a true thread or not, because you might be doing some sort of a wait, or the JavaScript or Python or whatever language we're using as an example may choose to run the other thread of execution, again, whether it's a true thread or not. But definitely, like, let's say that the JavaScript, they call it like the event loop. Let's say that you click 3 things rapidly. You have 3 different events being handled, right?
Right.
Within the same process.
In different order that you clicked on them.
That's true too, because yeah. But then if like one of them blocks, it's going to switch to the other one, and then come back to the first one. So I definitely think there's still some things to consider there. I don't know how they handle it.
So one of the difference in organization is that when you click on those 3 things, they all come back to the main thread, right? And so you can still kind of like organize them, right? While in multi-threaded, you have no idea that anything happened, right? I don't know if I'm making it clear. In a multi-threaded environment, it gets swapped like underneath without you knowing there. You don't even know there is another thread running. While with asynchronous, it's kind of like, well, everything is still under this one main thread, so you kind of have this manager thread, right?
Right. Yeah.
So it's kind of like you handle this, the way you handle the asynchronicity or synchronicity of the events is really up to you. Well, in the other one, you don't have any control over it, besides you doing a synchronize and logging and that kind of stuff.
So let me just, because we can go in circles, summarize or conclude or ask. What I'm hearing is from Diego, and this is kind of what I was getting at, which is either over time we've, as JavaScript web developers, have started to structure our code in such a way, or the frameworks or the libraries that we use do things in such a way under the hood that it kind of avoids some of this issue. But I'm also kind of hearing that even though that all may be true, there might be some concern that Don isn't necessarily able to articulate right here. I don't know. It could go either way. So, but yeah.
I mean, I think your original question is, how come we don't see this in JavaScript that much? And I would say it's due more to the kind of apps that we're writing.
Can I use a short example that I think everyone will get, which is, so let's say I have just some JavaScript code that runs in my website. And first I set some variables. Then I call one asynchronous method, which changes the value of a global and increments it by 1.
Right.
And then underneath that, I have another asynchronous method, and it increments that same global by 1. I personally, as a JavaScript developer in the browser, never can assume which one will fire first or second, and I write my code in such a way that I don't really care. I guess the question is whether the second one is kicked off first or whether it bounces back and forth in the thread. But let's say the second one is kicked off first, that tab only has one thread ever going, and maybe that's wrong. But
No, you answered the question. You don't know when they're gonna happen, so you write the code so it doesn't matter.
right, I always write it to where it doesn't matter. I'm not sure if Don is saying that even though that's the case, there could be something that could mess up with the
Well,
way that they bounce, very, very extremely low level that they bounce information.
the difference is the kind of scenario Don sets up is that you care what the current value is at the time the async gets run.
Is that true, Don?
That's
Yeah.
what you get out of
Yeah.
sync.
Yeah, no, then from my perspective, it'll never happen.
But
Yeah, depending on what you're doing.
with you have like a panels inside of a browser, right? With tabs, and each tab does a different async call, comes back, does some calculation that takes time, right? And then sets a global, sets the tab to like 1, 2, or 3, whether it's like a tab 1, number 2, number 3, right?
Okay.
And then highlights that one tab. If you write this code, and I click very quickly on 1, 2, and 3, all 3 things are gonna fire almost simultaneously, and say the order is 3, 1, then 2. Right? There pretty much almost, unless you do some weird coding in it, there's almost no way for you to, even though you click 1, 2, and 3, if you come in 3, 1, and 2, the state is gonna be 2. Because that is the order that they came back and the order that they get executed. So let's put it this way. Let's say 3 comes back and it does some of the calculation that takes time. And while it's doing the calculation that takes time, 1 comes back, right?
Okay.
In the process, the thread is not going to switch to 1 until the callback is executed. So it's gonna, the way it's gonna happen is that 3 is gonna finish doing all of the callback, set a state, then switch to 1. It kind of goes into a queue at that point. They switch into 1, does all of it, and then switches into 2, and then does all of it.
What happens if one of those things blocks?
My own things, that I click 2 or 3 things and they happen in the wrong order, but they did happen in the order that they return.
So I want to hear Don's question, but I guess I agree with Diego. Async is different than multi-threading. It's just a different level, and maybe there's some clashing that we're unaware of. But Don,
right. Because generally, like in multi-threading, let's say if it was multi-threaded, if in the middle of my callback to 3, 1 returns, it will start executing 1. Before, let's say like it takes less time,
right?
It will set that stuff faster and earlier than my 3 tab.
Yep.
Well, in JavaScript, it doesn't happen.
Don, what was your last question, I guess?
I was just wondering, because so JavaScript apparently tries to execute whatever it's running to completion before switching. context to something else, right? Is what Diego's
Right.
saying. What happens when you introduce like a blocking action, though? Will it switch context to something else and then come back?
We mean a blocking action.
Like, let's say you do a sleep, or you read something. I know this isn't too applicable in JavaScript, but
it probably does. It probably does not bounce. But do you know, Diego?
One, there's no sleep in JavaScript.
Well, yeah.
What about doing a like a AJAX request that's not asynchronous?
Well, then it will be blocking, right? So nothing else is executing.
It doesn't bounce.
In that thread, but does it try to go and process other threads?
No.
I'm using thread generally to say like.
No, I don't think it does. No,
it blocks everything.
It's blocked,
it just sits there.
It doesn't know to the next line until it's finished.
Probably a good example of that is how many of us have froze our browser with a loop in JavaScript?
Right.
Completely white.
So let's say you call an asynchronous call, and then you call a synchronous call. In the middle of synchronous call, the asynchronous come back. It doesn't handle the callback until the synchronous call is finished.
Yeah, so there's absolutely no context switching in JavaScript.
That's our assumption right now, yeah.
Yeah, and so then that's why there's no, it's not kind of topic in JavaScript, I guess, this type of thing.
It is a little of a topic with web workers. Because web workers, you actually, you do spawn pretty much a new web page with new scripts. And that's pretty much like, it's almost like you're creating a new tab, a new iframe. I don't know that they're working on it.
Right.
That has its own thread.
All right, cool. Thank you very much.
2 or 3 web workers doing, like, messing each other.
That helped me. Okay, so yeah, it says skip this if you don't have to worry about multi-threading, but we'll go over it. Basically, they just say that they go into the details. I think it's all pretty obvious, but it's like suppose 2 calls to get instance are made at virtually the same time. For example, the first thread checks to see if the instance exists. It does not. It goes into the part of the code that will create the first instance. However, before it has done that, the second thread has also looked to see whether it exists, and it's null. So it goes and creates it. Blah blah blah. Just the way that normal, what Jeff would say, race condition can happen. And blah blah blah. Now, of course, that's a bad thing. Both threads now perform new on the singleton object, and just talks about how it could be a problem or not. And generally, we would think the whole purpose of a singleton, it would be a problem. But if the singleton is absolutely stateless, it may not be a problem. If it has a state, just goes into yes, it would be a problem. And I'll just list off the reasons. Inconsistent state between threads using if the object creates a connection, there will actually be 2 connections. If there's a counter used, there will be 2 counters in C++, regardless of state. This would probably cause a memory leak because it would only delete one of them after it goes into it. Could be very difficult to find these problems. First, it's very intermittent. Second, it mentions how any other object that's going to use that singleton is only going to use the second singleton that was created for the rest of its life, or maybe it was the first one. But either way, how there will be 2, but only one object will be using one of them, and all the other objects will be using a different version of them. And this can actually be difficult with the count. Goes into some solutions. Solutions could be maybe synchronize everything, but this could cause a severe bottleneck because all the threads have to wait for the check on whether the object already exists. I'd love to go through that exercise because I I'd love to see on what level everything happened, because I just kind of glossed over it, but I guess in theory I could understand it. Perhaps you could put some synchronization code in after the null check. This won't work either, they say, because it'd be possible for both calls to meet the null at the same exact time, I guess. The solution in some languages, all languages, at least some languages, is to do the sync after the test. That way the sync is only happening once. So it's basically, it goes back to check to see if it's null. If it is null, create it and then return it. But instead of just doing that, synchronize just once and double check. I don't know if anyone has any questions, comments, experience with that, but I think that probably makes sense. Pretty straightforward. Okay, so before I go into that, it's the feature behind the double check locking is basically that it's avoids unnecessary locking. But there's a problem. It was soon discovered when converting it from C++ to Java that it did not work for Java. This basically has to do with the Java compiler, its optimization efforts, just some details in that. I don't want to read it word for word, but just in the way that I guess the Java bytecode or whatever it is works, it could optimize and totally take out certain trees of logic, and yeah. I guess there's this thing in C# called volatile. Has anyone used that? Maybe not. I programmed some small C# stuff, but nothing complex. Never had to use volatile. So with C# you could avoid this problem by doing volatile. In Java, you could potentially use what's called take advantage of the class loader. Never use Java on this level. Does anyone ever use the class loader or even know what that is?
I don't know the term there. Below he talks about using inner class. I've used inner class. I've used anonymous inner class. I don't know it. I guess he's talking about that's how Java loads classes.
Right. Yeah. Okay, so yeah, I'll finish there and just say that he mentions how some people thought that this was proof that patterns were overhyped, and how patterns should be able to be transferred from language to language very easily. He thought that that wasn't the case. And he thought it was even better reasons why a pattern existed. Yeah. Okay, some field notes. If you know you're going to need an object and no performance issues requires you to defer instantiation until it's needed, it's simpler just to have a static member contain a reference to the object. In multi-threaded applications, you can't necessarily use singletons. You have to use this double locking or something similar. Stateful singletons should only be used sparingly, basically, because of global data issues. Stateless facades can be instantiated with a singleton. Sorry. And that's about it. All right. The common patterns. I think most of us probably use singleton in JavaScript. And some talk about factories, but I skipped over factories. Review questions. Anyone have any desire to answer these? What type of pattern is the singleton? What general category does this pattern belong to? What do you think, Forrest?
One of it, I mean, because it handles the creation, it affects is creational. What's the other one? What's the one that affects data? There's the behavioral, structural, and what's the third one? It's what's the third one? I would say somewhat. Sometimes it's behavioral because we're syncing. Behavioral structure. Where's the three? I thought the creational, behavioral, structural. Was there? Did I miss one?
It's a factory.
All right.
Yeah, they should be.
Factory. What is the intent of the singleton pattern? It's basically to make sure that it's only instantiated once. How many objects is the singleton responsible for creating? One.
One, yeah.
Is that a trick question? One? Or,
Yes.
the singleton uses a special method to instantiate objects. What is this? What is special about this method? Well, I guess the initializer would typically be private. Not that it makes it special.
The special method is the factory method, which by convention is like instance or get instance. It's the only way. You can't use the constructor. You have to use it.
All right. What is the difference in when to use the singleton and double check locking? It just has to do with multi-threading. Interpretations. Is it better to have objects be responsible for handling their own single instantiation than to do it globally for the objects? Why or why not? Of course, he says, yes, it is better to have the objects be responsible for handling their own instantiation. Unless I flip that one.
Yeah.
But basically, he said don't have an object that manages.
In general, the less you have to know, the better. So when things handle themselves, that makes it easier for you to use.
Yeah, it's kind of like locking too. Is if you mess up in one place, then you messed up everywhere. So it's better for it to handle it on its own.
Perfect. Why do you think the Gang of Four called this pattern singleton? Is it an appropriate name? What is doing? Why are we not? I don't know. Anyone have any thoughts about why they called it singleton? Makes sense to me.
It's a single object.
Yeah.
You know. So yeah, it
Seems appropriate.
seems to match pretty much what it is.
When it was discovered that the double check locking pattern, as initially described, did not work in Java, many people saw it as evidence that patterns were overhyped. I drew exactly the opposite conclusion. The guy loves to say that in this book. He'd be like, no, this is even more proof. Do you agree with this logic? Why or why not?
I feel both reactions are over. Like the first one is just haters. See,
Right.
this sucks. And then the other one's, no, it's even better. It's like, oh. It's like languages are different, so things are going to be different. And and if you ever look at like Peter Norvig has this talk where half of the 24 original design patterns you don't need in Common Lisp because Common Lisp just does it automatically. It doesn't mean it doesn't work. So no, but the support for the language, sometimes you don't need it. Some patterns exist because the languages can only do things in a certain way. Like in Ruby, because you can monkey patch, you don't have to do things in a way, but you have to do things in Java because you can't monkey patch. That being said, monkey patches can be dangerous and you can mess things up. But it's like you're not limited by certain things. Or in some places, like I don't know that you can you make a Ruby constructor private?
Haven't tried. I was thinking that it must be possible.
If you do a private for initialize, does that make it private? Does that mean what happens? It's like I have to try. But I'm just saying, long story short, is some of these methods don't work across other languages because languages are different. So that's all I can say with that. So it didn't work here. Well, then you shouldn't have done it that way.
Yeah, I forget. I've been watching a lot of the show Mad Men, and I guess I see. Not that I need to go here, but I personally see the people that thought it was evidence that it's overhyped. It's a little kumbaya, little idealist. Yeah, sure, great. We'd love everything to be mathematical and work out perfectly, but programming languages are definitely not made the same way. So I don't know how you could ever blame a pattern or be like, oh, this pattern concept is horrible because it's not directly translatable in implementation. That's crazy to me. It's a little kumbaya-ish. Any thoughts? Any remaining last comments?
That's it. It's like, if you're a Ruby on Rails programmer doing back end stuff, there's not a lot of opportunity for singleton, especially if you got to do everything in 30 seconds with a Heroku thingy. So as something that lives a short time, this is not a big deal. And actually, and his technique of doing, get the instance that already exists, that's also known as, memoize parameters. We do that all the time. They say the singleton, it's singleton-esque in that we only want to instantiate it once. It's a technically singleton, it's halfway there. But the whole point is this idea of caching for persistence. That's one thing the singleton does. This idea of get the object in one way, that's kind of a factory. It's global data. Like singleton is a combination of some things. So it's appropriate for some things, but in the aspect of something that's responded to in a Rails controller, not so much. Now, on the other hand, if you're writing like a daemon, like all our background foo jobs, that becomes more appropriate. Instantiate once and just leave it there. But that being said, does it have to be a singleton? Could it just be a class?
Right. Yeah.
Depends how you program it.
Does anyone use singletons in Ruby on a weekly or monthly basis? I'd say even quarterly basis. Diego, do you use singletons?
Sometimes I introduced one recently, but it didn't make much sense. It helped me a little bit, like it was more of a code organizational
thing
and for performance.
And I guess, I'll have to look back at the factory stuff.
It's a standard lib thing to do singleton that I believe is thread safe. It's built into Ruby. Let me look it up. It's built in. It's a built-in module, singleton, Ruby 1.9. Yes, so you can literally just include the singleton module, and then class.instance does the thing.
Cool.
So can't do that in Java.
Cool.
So back to the whole language are different. Well, I just proved that design patterns are useful now. I said, no, it's just like you took this idea, which handles a number of concerns, and it's just easier in Ruby. Just like all the magic that RSpec does for making a fluid language to do their assertions. It's just easier in Ruby. And actually, if they did not see it in Ruby, it never would have made its way into non-Ruby programming languages. But once they say, oh, you could do this, and they came up with something that is somewhat similar, it's just easier. Some things are easier. Some things are just not possible the same way. All right.
Well, thank you very much.
We managed to stretch this third chapter the whole hour.
Yeah. All right.
All right. So next week we'll pick up the factory and then I guess go to the other one, 22. So slightly out of order. Who should we pick for factory? Sam looks like he's wanting to do the factory.
I think Scott.
If Scott does not want to do it, I'll do it.
Okay. So I doubt factory is going to take the whole hour. So we should do 22 also. All right. We'll bounce it off Scott if it's not Scott there. And we'll go with that.
Sounds good.
Maybe Sam will do 22. All right. Enjoy.
See.
Oh, yeah, before you guys, I got something to mention after I turn off broadcast.
Okay.